طيب بسم الله الرحمن الرحيم. So we started to talk about SSH, secure shell. We talked about the fact that SSH, like TLS, it actually performs a tunnel, except that this tunnel is mainly using one long-term connection, unlike TLS, which uses parallel connections. And then on top of this, it uses first user authentication, which is one of the services in SSH. Again, unlike TLS, which uses the handshake protocol in general, which might use different ways of authentication, but here we have the concept of user authentication, which is different from the server authentication. And then we have the connection protocol. Here, the connection protocol, as we said, it can use like remote control connection, like FTP or Telnet, and also it can use some اللي هو اللي بنسميه X12 or graphical control, or other types of services as part of this connection protocol, which we will talk about today. We also talked about the fact that the client uses different ways to, or two possible ways to authenticate the servers, either by storing manually the public key of the server directly at the client level, in which case, or using the certificate authority. So either you maintain all the public keys of all the servers that you want to communicate with manually and locally at the client, or you can only store the public key or the certificate of the certificate authority, and from the certificate authority you can authenticate all the servers. طيب, so in terms of connection handshake, so you will find lots of similarities, except that also there are some differences compared to TLS. So first, because SSH works on top of TCP, so we'll find that you have the normal establishment of TCP connection. So here, I'm expected to see like send, فاكرين اللي هو send, and then acknowledgement, send with acknowledgement, and then acknowledgement, right? Remember this three-way handshake for TCP? Right, so the TCP connection has been established, and again, TCP header is not encrypted, it's not touched. So TCP is the underlying transport protocol. On top of this, we have to establish the security context. So this is done using these phases. This phase is for initialization. This phase is for the actual key exchange, right? And this phase is similar to the cipher-spec change. If you remember, it's just like we agree that we are going to use the cipher-spec keys that have been established here. We confirm to each other that we will use it at this point to secure this connection. And then at the end here, we have the services. And of course here, I'm expected to see the first service that should start is the user authentication. Bravo عليك. Yes, is the user authentication. They are mainly using user ID and password and so on. Okay. So here, the first phase here is for initialization. In this phase, what we negotiate or what we agree on is what are the techniques that we are going to use, okay, to perform mainly key exchange. Okay, so the first is key exchange. Okay, and what are the techniques that we can use for encryption, okay, and for MAC, okay, and the fourth one is for compression. Are we going to use compression? Because compression also is optional, similar to TLS. Here is also a optional, right? So here the first initialization message is for the client to initiate the security context communication by saying that I want to send the protocol version and the software version. So this message it looks like this really. It's like the client is sending to the server saying that, hello, I'm going to use SSH2, okay, which is the protocol version, and I'm going, and this is used as part of a software. So software like what? Like POTI, مثلا, or مثلا SSH client by certain company or something like this. So here I'm going to use POTI client version 9 point whatever, okay? So this is how the message looks like really. And the server responds back by saying, okay, so I'm also using SSH2, but I'm using this as part of مثلا Ubuntu server, whatever, okay? So this is just the first initialization step. And then the client will send the SSH message key initialization. Here the key initialization sends two pieces of messages. Very important, huh? Two pieces of, the first message, similar to TLS, I'm going to send the possible ways to perform key exchange. I'm going to use مثلا ايه Diffie-Hellman method, or if Diffie-Hellman is not available, then I can use RSA, or I can use elliptic curve, whatever. So I'm going to send all the possible techniques, and also this is one. Number two, I'm going to send the parameters, the public parameters that are used as part of it. So, for example, in Diffie-Hellman, I'm going to send the alpha and Q. Remember? Alpha should be the primitive root of Q, right? So I'm going to send the alpha and Q. So if we are going to use Diffie-Hellman, here are two numbers that we can use, and so on. Okay? So the server will respond back with the same thing, but confirming back. Here the server would say, okay, so we can use Diffie-Hellman. Okay?
So it will pick one.
It will pick one, right? It will pick one of these available methods, and it will agree on this method. Okay? So here at this point, we have exchanged alpha and Q and all the required parameters to start the process of key exchange. Okay? Remember also the client here at this point, the client has another piece of information about the server, which is the public key of the server, which is already stored locally, right? Or the certificate of the certificate authority, which is responsible for authenticating the server, right? So this is also done here. So in addition to the alpha and Q and everything, the client also has the public key of the server, right? So the key exchange, the key exchange itself, this is actually, it should be called authentication and key exchange, because the server authenticates itself to the client. How? Well, it says, okay, so if we are using Diffie-Hellman, I'm going to use the alpha and Q. I'm going to generate a number and say, so this number is X, for example. So I'm going to say, I'm going to calculate alpha to the power X mod Q. And this will be مثلا some number here, okay? So so here I'm going to use the number and come up with Y. So the server will send first the alpha Q. So actually alpha and Q are already exchanged, okay? So I'm going to send Y, and I'm going to send with Y the MAC for the server. This MAC is some string or signature, okay? And it's encrypted with the private key of the server, صح? because this is for authentication. And then the client will verify this using the public key of the server, right? So this is as part of the key exchange. And then the client will send back saying, okay, so here is my generated number based on the alpha and Q and so on, and they will perform. So at this point, the client and the server, they have a master key, okay, as at the end of the Diffie-Hellman, right? They have the master key, and they also generate both at both sides, they generate a hash. This hash is like a number, okay? This hash is also very important. So a master key and a hash, right? From the master key and the hash, we can generate all the other pair of keys. Also similar to TLS. Except that what's missing here is the client user authentication, which is done as a layer above this key exchange, right? It's done separately. Here, okay? After we finish all the key exchange and the server authentication, right? We do the client user authentication. Fadl.
Now the MAC is authentication for Y.
The MAC? No. The MAC, yeah, that's a good question. So the MAC is what you are sending a message, okay, to the client, right? So this message, first you are going to calculate the signature, and the signature is going to be encrypted using the private key of the server. Okay, not only the Y, the entire message, because here you send other things which we don't have to talk about. So not only for the Y, for other things. Okay. This hash, it gets generated again using pseudo-random function based on all the strings that have been communicated before. And you get all the texts that have been communicated before, right? And then you generate a hash out of all the communicated messages. Okay? So the master key is secret. The hash is not necessarily secret because it's based on the strings that have been generated before.
It's like an initial vector.
It's like an initial vector, yes. It's like, yeah, some kind of initial, except that this hash, it's used to generate the initial vector, as we will see in the next slide. Okay, so these are this phase is just a confirmation from the client and server that whatever we have agreed upon, we will use it for this current message. اللي هي مقابلة للcipher spec change message اللي هي بس one flag. يعني I'm just confirming that this is the spec parameters, the cipher spec parameters that we are going to use as part of this connection. ماشي؟ تمام كده؟ طيب so until now we have agreed on a master key and we have agreed on a hash, right? Which is agreed upon on both sides. We have done the server authentication. Okay, server authentication is done. So now we need to do the user authentication before we start the real communication. So we need to talk about the actual user authentication, how it's done, and then we need to know what are the possible ways to communicate services back and forth between the as part of this message. We have to agree upon all the. So we will use the master. So this is the master key, and this is the hash. Okay, and we use these two using some hash function to generate by IV. And again, because we are talking about a reliable connection, bidirectional connection, we have to have a key in each direction. So we have IV from client server, IV from server to client. Similar to TLS. In the case of TLS, we say it's a client write key, server write key. This is exactly similar, but the name is slightly different. So we have the IV, and we have the encryption key, and we have the integrity key. Okay, and for each one we have to have pair of keys, right? One from client to server and one from server to client. This is exactly similar to TLS. Okay, any questions so far?
What is the ABCD?
So this is it's a fixed string, and this is a session ID which is agreed upon between the two. Okay, so we will use these numbers to hash it and provide the IV, right? But these are the two important things, the master key and the hash. This is the most important things, because the other fields are fixed. These are the only two generated fields. ماشي? And agreed upon possible. Again, similar to TLS, with a slight difference here, we see that the payload here, which excludes the TCP header. TCP header is not part of this at all. Yes, TCP is lower. خلاص ما لناش دعوة بال TCP. We don't do anything with the TCP header. It's not encrypted. It's not touched. And again, this is optional. Okay, and the standard says that it's optional, so you could you could have some compression, and you can choose not to use any kind of compression. Again, why do we use compression? To simplify or to reduce the complexity, because again the encryption complexity is proportional to the size of the block. So if the size of the block is reduced, the complexity of the encryption and the MAC gets also reduced. So it's by choice. ماشي? So again, what we do as part of the protocol is that here we have the packet length, and the packet length here refers to the compressed payload length, right? We have the sequence number for a replay attack, bravo عليك, and we have the padding length, right? For again to confuse the crypto analysis. It's exactly similar to TLS. The only slight difference here is that in TLS we used to produce the MAC based on the unencrypted date. Here we do the MAC after we do so first we do the encryption for the payload, and then we do the MAC after encryption. Is there any preference for one sequence over the other? No. Although in IPsec, remember in IPsec we kept saying they kept saying that okay, the standard prefers to store the MAC of the unencrypted text for future. That's not really a real benefit. There's no actual benefit if you do encryption first and then MAC, or if you do MAC and then encryption. There's no actual benefit.
Now both MAC and encryption are encryption. So MAC is
No, but the idea is, should you calculate the MAC based on the unencrypted text first, and then you encrypt the plain text and produce the encrypted text? Or you do the encryption first and you calculate basically the signature, calculate the signature on the encrypted text. Okay? Is there any preference for one over the other? No. You can do either. Encrypt first and then calculate the MAC, or MAC and then encrypt the text. Doesn't matter. Okay? In some standards they do one, on the other standards they do the other. It doesn't matter. In IPsec they said that the standard prefers or recommends that you do the MAC on the plain text first. Why? Because we want to store the pair of the MAC and the plain text on the server. Okay? So if the same text is sent multiple times, we don't have to calculate the MAC again, right? But really that's not a real benefit, because you end up really sending different text every time anyway. Okay, so that's, which is exactly similar to TLS. So these are the possible techniques for encryption, for MAC, and for compression that are listed in the standard, which is again it's for encryption, for MAC, and for compression. The green ones are the minimum that any implementation for the standard should support. Okay, and that's why we need to negotiate that, right? Because in some, مثلا POTI implements the minimum. مثلا, so POTI will use triple this with cipher block chaining for encryption, and will use AES and use AES also for encryption. For Mac, it uses only SSH1 and SSH196, whatever. It uses those two for Mac, and it uses no compression. So an implementation for the standard may use all the green ones, and that's it. So it's still compliant with the standard. Other implementations might implement actually all these possible techniques. So that's why during the initialization message, we need to negotiate the possible potential methods for Cypher, for Mac, and for compression. So the minimum is to have no compression. If you want to have compression, then you can use the zlib compression, right? Which is, طبعا, it's a lossless compression. You cannot afford losing any information from the actual. So this is about for user authentication. So for user authentication, in many ways, 90% of the time, use the password. Okay. However, you can use actually public key. So again, it's done anyway as an upper layer. Upper layer to the SSH, the establishment of the SSH security context. So you can have public key here. You can use the public key of the client in that case. ماشي? Here the public key of the client can be used for authentication, which is similar to the server, but in that case the public key of the client should be stored in the server. ماشي? So the client sends a message to the server that contains the client public key with the message signed. But طبعا هتقول لي ايه? How can I send the public key to the server like this? By this stage, we already have a secure tunnel, so everything is sent through the tunnel is already encrypted. خلاص. فاحنا we have a secure tunnel already established. ماشي? When the server receives this message, it checks whether the supplied key is acceptable for authentication and so on. طيب في هنا بقى في the password يعني ايه؟ خلاص it gives you a prompt to enter your user ID and password to authenticate the client. في هنا حاجه اسمها ايه؟ host based. ايه الفرق بين host based و public key? Here the public key is the public key of the application instance, which is in that case the party مثلا. يبقى party uses a certain public key to authenticate the SSH client to the server. Okay? Here, host-based public key. So it's not about the host base of the client. It's the host base of it's the public key of the host itself. So it's not of any application instance. It's a public key that's assigned to the host itself as a whole. So this is the difference between this and this. This public key is for the application instance. So for example, if you have two clients running on the same host, they will have different public key, right? But here, if you have two clients that uses the host-based method, both clients, they will use the public key of the host itself. So this is the main difference between the two. In any case, 90% of the time, we use the username and password. طيب. هنا بقى there is an interesting concept which is defined as part of SSH, which is the channel mechanism. This channel mechanism is totally different. It does not exist in TLS in any way. Why? Because as we said before, if we have مثلا a client here, and this client uses TLS, okay, and this client happens to communicate with a server, mainly مثلا web server or email server or something like this, right? So this server also uses TLS, okay? So in that case, we have to establish a session between the client and the server, and in this session, we may in fact use different interactions between the client and the server, and each interaction is performed as part of a connection. Each of these connections uses a tunnel, right? So So these connections either done in parallel or sequential, but they are multiple connections, and each interaction with the server is done through connections, right? Type. This is for TLS. Assuming that we have another client that uses, in that case, SSH. This client happens to communicate with the same server, okay, through SSH server, right? So here we have also SSH, okay? So in that case, we establish برضو a session, SSH session. This session performs some interaction with the server through one long-term connection, right? Which is done again as part of a tunnel, right? Inside this connection, if we have different interactions with the server, we have to have برضو different interaction with the server. For example, you are communicating with the SSH server in order to download 100 files. Some of these are interactions with the server. So in that case, you actually establish different channels, logical channels. Channels are logical stream of segments, okay, which represent a certain object or a certain item, like a file. ماشي? So different interactions for SSH are done using the concept of a channel. A channel runs on top of the connection. ماشي? طيب, what is the difference between these two? What is the difference between these two? Let's analyze. First, channels. All types of communication using SSH are supported using separate channels. So different interactions with the server are done using the channel. The channel on top, you can think of the channel as in the application level. But these channels, برضو, if I want to download some files and stuff like that, these channels or this stream of segments that are coming, they need to also perform some kind of flow control, and similar to the flow control وكذا زي TCP. So so either side may open the channel. So now, since we established the connection, the client may say, I want to upload. So the client will upload something to the server, or the server would say, okay, I want to send some files to. So either side can establish a channel. So the client always initiates the communication by establishing the connection. Once the connection is established, anyone can send anyone anything through different channels. Type. So for each channel, each side associates a unique channel number. So there is a channel number. So if I have 100 files, each file will be downloaded in a separate channel, and each channel will have a channel number. Type. So channels are flow controlled using window mechanism. So I need to do flow control on the level of the channel, which is different from TCP. This is done on the level of channel. So when it comes to flow control and congestion control, we need to discuss about the pros and cons of each of these. Because again, SSH, why did they select SSH to have one long-term connection as opposed to have separate, possibly parallel connections for each interaction? Because SSH wanted to be simple. ماشي? SSH wanted to be simple because of the fact that, okay, so when I use one connection, I don't have to maintain the connection context for multiple connections, because each of these connections you have to maintain a separate socket, صح? And separate security context for each connection, because each connection is a separate tunnel, right? So each of these tunnels may use different. Of course, all of them are extracted from the same master key, but you have to have different keys, right? صح? For each connection every time. Based on what? Based on the master key and maybe the IV and some dynamic information, you establish temporal keys or temporary keys, right? For each connection. So here, I need to maintain connection context for each connection, which is different socket, and I need to maintain security context for each connection as well. Okay? Which is done from the session context, right? But I have to have separate security context for each connection. So this is complex type. This complexity, did I benefit from it in any way? The answer is yes. Why, Ba? Why? this concept يعني is important. Maybe we did not study it in network 1, but يعني people who have gone through master level في advanced networks وكده they have learned about it. So basically, if we assume that the server shares يعني a link in the network infrastructure, and this link has a bandwidth of B. Right? TCP has maintains, in addition to طبعا للreliability, 100% reliability, and which we talked about in network 1, it maintains fairness. Right? What this means is that if we have a bandwidth of B, this bandwidth of B will be divided equally between all these connections. Right? So if this client has n connections through TLS and one connection on SSH, okay, what is the bandwidth share for each of these connections? It's actually B divided by n plus 1. ماشي؟ مفهومة كده؟ TCP maintains fairness throughout all the connections to a particular machine. Okay? طيب, what is the implication of this? The implication of this is that if TLS has all these connections in parallel, in fact, TLS eats more bandwidth, more than SSH. يبقى this complexity, in fact, comes with a benefit, implicit benefit. And this is, in fact, what happens in BitTorrent. In BitTorrent, ليه أنت when you download, أكيد all of you tried BitTorrent at some point, or يعني Gonatella ولا الحاجة دي. So if you say, I want to download this movie, okay, some clients allows you to download through multiple connections. So when you create multiple connections to the same server, you download the file faster. صح? Why? Because if this server has a certain bandwidth, okay, the more connections you have, the more bandwidth you can tap into. You can tap into more bandwidth. So you can download the file faster by establishing more connections. But of course, you have to pay cost for this because you have to maintain all these connections. You have to maintain the connection context, and in that case, you have to maintain also the security context. ماشي كده? So if you have TLS and SSH competing, chances are TLS may in fact eat maybe faster. Okay? Because here, if you are downloading 100 files here, okay, and you're downloading a movie here, chances are the movie will eat more bandwidth, which makes sense because movies, يعني, it's interactive and should be. But here, if you download 100 files, it's fine. If you delay a little bit, it's fine. Okay. But this will be at a disadvantage if we are using a graphical user interface or anything interactive. So in general, TLS uses multiple connection in this context, although it's a little bit more complicated, but it has a benefit of tapping into more bandwidth. ماشي كده؟ Any questions so far? But other than this, يعني the channels allows you to create multiple interactions with the server. So the concept of the channel is very easy. يعني this is very easy. Once we establish, خلاص here we established all the security context in the last slide. So here بقى anyone, either the client or the server, I want to open a channel. Okay. Once I want to open the channel, the other side will respond back with a confirmation, and then we start sending some data, and at the end I close the channel. Very easy. Anyone may open the channel, the other one يعني acknowledges, we start to send some, so whoever opened the channel will send data back and forth, and then at the end I will close the channel, and that's it. So this is very easy. I can do that. I can do channels in parallel or serial or sequential, برضه نفس الشيء. Except that again, these channels run on top of the same connection, which has one security context. ماشي؟ طيب. Here بقى in terms of the channel types. So you can have a session with some remote control. So this is 90% of the time I use it for this. So this is for as part of Telnet or FTP. So I want to open a channel with another SSH server in order to write some commands, download some files, which is done as part of Telnet or FTP. Except that here, طبعا, we're talking about secure FTP or secure Telnet, right? So this is good, and this is what's done most of the time. اللي هو remote execution of a program or downloading a file or something like this. There is also the graphical mode. Not many people try this, but SSH allows you to have a graphical user interface with the server. So you can interact with the server in a graphical way. Okay? So you have a GUI session in that case, and you can control the server using a graphical user interface. Those two those are very interesting functionality as part of SSH, which is part of what we call port forwarding. This is a very, very nice feature that SSH allows you to do, and many people, they use this, especially people who are specialized. Because this can be used in replacement of VPN. You can use this, and you don't have to use VPN. But this is, in fact, it's a little bit tricky to configure. So experienced users, they use this method. Unexperienced users like ourselves, we opt to using a VPN because it's easy. I connect on a VPN server, خلاص, everything is gonna be tunneled through the VPN. It's not, but here we're talking about securing a tunnel between two application endpoints, صح? Two application endpoints. VPN ملوش دعوة. VPN, I can secure the entire traffic between host and a router, host and a network, or something like this, as we said before. So what is the difference between these two types of port forwarding? By port forwarding here, I mean that I want to connect to a restricted website on dark web ولا حاجة زي كده. I want to do some fishy transactions on a restricted website. Of course, this restricted website is actually forbidden by a firewall. مثلا أريده will restrict you from. لا طبعا, based on a rule, the firewall will say, okay, so based on a rule, I can recognize that you want to connect to this restricted website. I can see that as plain text. Plain text. I see the application information, and I see the port number, which is مثلا port 80 ولا حاجة زي كده, and I see the URL. The URL itself is not encrypted, right? So I can see the URL. So this is a restricted website. So I will stop the communication, right? Instead, SSH will say, okay, so I will encrypt everything in a tunnel, right? So port forwarding here allows you to say that in SSH, if I send you anything with a port number, مثلا, let's say مثلا port number 1, 2, 3, 4, this is the local port number. That's why this is a local port forwarding. And I'm sending you this from مثلا, let's say from a local machine, .0.0.1. If I'm sending you this, okay, then at the end of the tunnel, you map this to the restricted website URL بقى with port 8080. ماشي? So in the beginning, I will have to configure this. So if I give you this at the beginning of the tunnel, you change this at the end of the tunnel to this. ماشي? If I set up this rule, then the port forwarding will allow me to map this port number, some weird port number, to the restricted website. Okay? So this is the first use of it, which is called the local port forwarding. Another way of using port forwarding بقى لما يكون مثلا انت you have a server at your home network And this server is by default, it's hidden from outside. Nobody outside can see it. Why? Because this server is either blocked by a firewall or it has a private IP address that's not visible, it's not visible from outside. ماشي? So in both cases, your server by default is hidden. So how can I make my server exposed to the outside? Okay? So in that case, you have to do the reverse operation. You say that if the incoming traffic has a remote port, that's why it's called a remote port forwarding. If the incoming traffic has a remote port, because remember, in TCP, for any socket, for any communication, you have to provide the local port and the remote port, and the local address and the remote address. So you have access to all these 4 fields. You have access to local IP, remote IP, local host, remote host, right? صح? So the port forwarding either works on the local port or on the remote port. ماشي? So if the incoming traffic has a remote port of 1, 2, 3, 4, then at the end of the tunnel, change the remote IP address to this private IP address. ماشي? Which is like this. So here مثلا you have a home network. Okay? And your server is inside here. And here, this router is either blocking the access to this server because of some firewall, or this server has a private IP address. Okay? This private IP address is not exposed. So if I send anything to this network, I'm going to send it with the public IP. صح? So if I'm sending this to this public IP address and a remote port of 1, 2, 3, 4, okay, then the SSH that runs here will change the public IP, okay, and this remote port to a private IP with a port of مثلا 80 if I want to access the web server on this server machine, which is, again, it's hidden totally from outside. So here the key is whether I map the local port to something which I want to connect to a remote restricted website, okay, or I want to map the remote port, okay, to expose a local host which is otherwise hidden from the outside because of the fact that it has a private IP address or it's blocked from the firewall. ماشي كده؟ As part of this example, the server is hidden. It has a private IP address. So whenever here you see the remote port, map it to the private IP address of that server. So these are the 2 possible. So port forwarding is one of the most useful features of SSH. Many people, they use SSH only for port forwarding. They like port forwarding as part of SSH. And it's done using one simple command line. So once you connect on a server using SSH, okay, so you perform one command line, whether to do local port forwarding or remote port forwarding, to set up these rules at the beginning of the tunnel and at the end of the tunnel. Once this rule is performed, so each side will know that when it receives مثلا a remote port like this, it needs to change it to a destination address like this and a destination port like this. Or I need to work on the local port. Okay? So either I need to look at the local port or the remote port. So it provides the availability to convert any insecure TCP connection into a secure SSH connection, also referred as SSH tunnel. So the idea is at the beginning of the SSH tunnel and at the end of the SSH tunnel. So I need to perform a command line so that I need to do mapping at the beginning of the end of this SSH tunnel. the incoming TCP traffic is delivered to the appropriate application on the basis of the port number. Okay, either the local port number or the remote port number. ماشي? Example. So this is how it's done. So in normal cases, the client application, in normal unsecure cases, you use TCP. So in the TCP socket, it's maintained by what? By the IP address of the host that this application is running on, right? And the local port and the remote port. صح? And the IP address of the server. So this actually defines the socket in general. So you have local port, you have remote port, and you have local IP address and remote IP address. So this is in the unsecure way. So in that case, everything is exposed, it's unsecure, everything is plain text. So I can really put a firewall here, صح? Can put a firewall in the middle, and then I can block any traffic that I want because I see everything. I see the IP address, I see the URL, I see everything, right? So if this website, if this server application is actually a web server and it runs like a restricted website, right? So this is about the problem. The firewall can see this and can block it. So instead, I can use this secure tunnel to say, okay, so instead of sending this port number, okay, which is exposed, okay, I'm going to send this secure. I'm going to send it through the tunnel. You will not see it. So this X, so this X is sent through the tunnel. You will not see it. When you will see it? Here.
At the end of the tunnel.
Right? So at the end here, X is decrypted. صح? You will not see it. What you will see بقى is some kind of a secure connection, which is مش هتشوف أي حاجة. Okay? So the idea is that here بقى, whether you want to map this local port, okay, to the restricted website, or you want to use it for remote port forwarding. So this example here talks about the local port forwarding. So in that case, I need to see X at the end of the tunnel, and this X, okay, is going to be mapped to the restricted website. Okay, so the local port forwarding, this is the command line. So I'm going to use this SSH server. This SSH server is running at the end of the tunnel. Okay, and I'm asking this SSH server that whenever I give you a local port 80 with this local IP address, 127.0.0.1, please map it to this restricted website on port 80. ماشي? So this is the mapping that I need to do.
So it's like IPsec, but in a simpler way.
الIPsec قصدك يعني زي الVPN يعني? Yes, but here I'm giving it a rule at the end of the tunnel to perform at the end of the tunnel. I don't have to pass any restricted website here. I don't have to give any information about the restricted website that I want. So this command line, if it's done once and for all. It's done at the beginning, once and for all. As long as you maintain this long-term connection with the SSH server, any traffic that goes through this tunnel, okay, at the end of the tunnel, it will be mapped to this restricted website on port 80. So this command is done once and for all. ماشي? Remote port forwarding بقى it's the other way around. Here بقى when I tell you, so the only difference is that this is local port forwarding, this is remote. معناها ايه؟ Remote معناها when you see this as a remote port, not as a local port. When you see this as a remote port, okay, you have to use بقى ايه؟ In that case you have to use local host, اللي هو local host اللي هو private IP address بقى. مفهوم كده؟ This is the private IP address. ماشي؟ اللي هو as ماشي كده؟ So this is the difference between local port and remote port. Oh, and this is the through NAT. So either بقى blocked through NAT or blocked by a firewall that runs on your home router, whatever. But many people, they resort to this solution as a very cheap solution, even if you don't have access to the VPN, because the VPN you have to pay money sometimes, صح؟ فيقول لك لا يا عم أنا I will set up a free SSH server on my home network and I can use this as a cheap solution. I don't have to use VPN. And then you can give access to a particular server inside, not all everything.
تنفع لي مثلا واحد عنده مثلا سيرفر شخصي
سيرفر شخصي بالضبط. yes.
معلومات بس يسوي له اكسس من برا.
Right.
يستخدم SSH.
Yes, exactly. So SSH provides a very cheap solution for that matter. ماشي كده؟ طيب يعني خلاص هو ده كده this is the end of this chapter. We discussed TLS standards and SSH. ماشي؟ For TLS is used mainly for web client and web server. SSH أنت طلحة أنت جيت متأخر ما شفتش. So SSH is used for remote control, remote execution of program, or for finally for port forwarding, as we discussed, either local port forwarding or remote port forwarding. Okay.